Hello everyone, welcome to another video. We are going to do some identification of ions and gases questions of paper 4. Since you all know that there is a lot of uncertainty around these kind of questions because initially in O levels, the table of identification of ions and gases were not given. But this time, starting from this year, they are going to give you the table, the identification of cations and anions table. So the type of questions are going to change. And I have compiled a few questions that are pretty similar to what they have given in the specimen paper for 2023. So I hope this is going to help you and give you a basic idea about how is this chapter is going to be tested, right? So So solid E was analyzed. E was an aluminium salt, and some observations are shown below. Appearance of solid E and the test. The test one is that a little of solid E was heated in a test tube, and the observation is that colorless drops of liquid formed at the top of the tube. A little of solid E was dissolved in distilled water. The solution was divided into 4 test tubes, and the following tests were carried out. Complete the observations for test 2 and 3. Okay, so drops of aqueous sodium hydroxide was added to the first test tube. So we are talking about an aluminium salt. So when you add sodium hydroxide, aluminium ions give white precipitates. Observation would be white precipitates. When you add excess sodium hydroxide, white precipitate dissolve in excess. Right? You can see that in the table. Here, the analytical part is that they have just told you about that's an aluminium salt, right? So you should know now. So you should know from here that aluminium salt contains aluminium ions. Now, what about the test 3? Drops of aqueous ammonia solutions was added to the second test tube, and then excess ammonia solution was added. So again, white precipitate will form. White precipitate form, but in aqueous ammonia, aluminium precipitate remain insoluble in excess. So white precipitate form which is insoluble in excess, which is insoluble in excess. Okay, 2 further tests were carried out and the following observations made. Test on solution E. So in test 4, they added HCl followed by barium nitrate solution. And observation is no reaction. So far, the only thing we know about E is that it's an aluminium salt. Now he has told you that while reacting with barium nitrate, there is no reaction. That means that there is no, that's not going to be aluminium sulfate, because if there was sulfate in E, then this barium would have reacted with sulfate to form barium sulfate, and यहाँ पे white precipitate आता है. Since there is no reaction, that means it does not have sulfate ions. Okay, it's not a sulfate salt. Again, for test 5, with the aqueous sodium hydroxide and aluminium foil were added, and there was effervescence. Pungent gas was given off, and gas was turned damp litmus paper blue, red to blue. And this is the test for actually nitrates. Ammonia is released. Okay, so test 5 means it's going to be a nitrate. It's going to be an aluminium nitrate. So what does test 1 tell you about solid? Test 1 was on the previous slide, which said that a liquid is formed on heating E. Okay, so if this is an aluminium nitrate and on heating a colorless liquid is being formed, there can only be one possibility, and that was that aluminium nitrate solution was, or aluminium nitrate salt was hydrated. So when you heated it, water was evaporated and then got condensed. So it has to be that. Test 1 tells about solid. What does test 1 tell you about solid E? That it contains water, that it is hydrated. E is hydrated, or E contains water. Identify the gas given off in test 5. I already told you guys that it's ammonia. Ammonia. What conclusions can you draw from solid E? About solid E, we can draw a conclusion that solid E is not a sulfate, right? We can say that the solid E is a nitrate, and it's definitely not a sulfate, and it's definitely not a sulfate. That actually count as two conclusions for 2 marks, and this is going to be enough. And that it is hydrated. So hydrated wala part we've already written in the B section, in the B part. So test 5 states that the mixture should be warmed carefully. In terms of safety, explain why is it necessary to warm carefully. See, sodium hydroxide is caustic. It is a toxic thing. Okay, you don't want boiling mixture to uh, get out of the container in which you are heating it, right? So you can say, like acids, sodium hydroxide is also dangerous, but in a very different way. Sodium hydroxide gives you basic burns, right? Because it is caustic. Sodium hydroxide is caustic, or you can say it is irritant. Sodium hydroxide is caustic, so boiling carelessly, boiling carelessly can cause mixture to blow out or to come out. Okay. Okay, so solid M and N were analyzed. Solid M was iron 3 nitrate, and tests on solid M. Solid M was dissolved in water to form a solution of M. Solution was M was then divided into two test tubes. To the first portion of solution M, aqueous sodium hydroxide was added gradually until it was in excess. Uh, the product was kept for B. Okay, but are going to be the observations. Okay, so it's a nitrate and you're reacting with sodium hydroxide, so obviously ammonia gas is going to be released, which is going to turn red litmus paper blue. So paper, red litmus paper turns blue. Okay, or the product from A was transferred to a boiling tube. A piece of aluminum was added to the mixture, warmed gently. Any gas produced was tested. Oh, in fact, they said that the product was kept for B. So lead newspaper will turn blue here. Here the observations you can write since uh, it was what was the solution? Iron 3 nitrate, yeah. So iron 3 nitrate की observation like iron 3 shows a red brown color. So red brown precipitate will be formed with sodium hydroxide. Red brown precipitate will be formed, and with sodium hydroxide uh, they are going to be in red brown precipitate formed which are insoluble in excess. क्योंकि 2 मार्क का है तो आपको पूरा लिखना पड़ेगा which are insoluble in excess. Okay, so the next part is that after transferring to a boiling tube, a piece of aluminum foil was added. Now that's it's going to be a complete reaction. It was a nitrate, and then aluminum foil was added, and the mixture was warmed gently. Any gas produced was tested. So observation would be that red litmus paper turns blue, and the gas would be obviously ammonia. Okay. To the second portion of solution M, about 1 centimeter cube of nitric acid followed by a few drops of barium nitrate were added. Okay, so what was solution M? It was iron nitrate, right? So nothing is going to happen with nitric acid and barium nitrate. Maximum barium nitrate will be formed, so there is not going to be no precipitate, or you can write no reaction, no change. Okay, so the test on solid N. In test 1, the flame test was carried out on solid N. The flame became red. Okay, the flame became red, and that is an indication of lithium ion. Solid N was dissolved in water, and the solution was divided equally into one test tube and one boiling tube. In test 2, nitric acid followed by silver nitrate were added to the first portion of solute of solution N. So there is no visible change, which means that you're adding silver nitrate. So there is no silver chloride, bromide, or iodide. So there is no chloride ion, there is no bromide ion, and there is no iodide ion, because silver forms insoluble but clear salts with these three ions. So what about test 3? In test 3, dilute hydrochloric acid was added. The mixture was warmed and any gas produced was tested. And the observation of that gas was that potassium manganate changed from purple to colorless. There is only one gas that is a reducing agent. Okay, there's only one gas that converts, that actually makes oxidizing agents react, which means that that gas is a reducing agent, and that is sulfur dioxide. Sulfur dioxide. And if sulfur dioxide is being released, now it means that there is a sulfite ion. Okay, there are two ions. There one is sulfate ion, and then there is another ion called sulfite ion. Sulfate ion produces sulfur trioxide. Sulfite ion produces sulfur dioxide. So we already established the lithium part of it, and now we know the anion part of it. So identify solid N. Solid N is going to be lithium sulfite. Solution A and Solution A and solid B were analyzed. Solution A was aqueous copper bromide, and tests were done on each substance. We don't know about solid B yet. So test on solution A. Solution A was divided into three equal portions in 3 test tubes, right? So the A part says that the end of a piece of wire was dipped into the first portion of solution A. The end of the wire was then placed at the edge of a roaring Bunsen burner flame. What would be the observation? So you are talking about the copper ions here. The copper ions produce a blue-green flame, a bluish-green flame. Okay, it's a flame test for copper. To the second portion of solution A, aqueous ammonia was added drop-wise until it is in excess. So we know that blue precipitate of copper hydroxide will be formed. Blue precipitates are formed, and they have added ammonia until it is in excess. We know that copper precipitates dissolve in excess ammonia to form a dark blue solution. So blue precipitate are formed, which dissolve in excess ammonia to form a dark blue solution. A dark blue solution, yeah, a deeper blue solution. Okay. Now to the third portion of solution A, dilute nitric acid followed by aqueous silver nitrate was added. So since it's bromide, that's going to be a test for bromide. Silver will react with bromide to form silver bromide. Okay, and silver bromide has cream precipitates. You should be familiar with some precipitates, like silver chloride has white precipitates, silver bromide has cream precipitates, and silver iodide has yellow precipitates. Okay, so the test on solid B. Solid B was dissolved in water and then mixed together. This then made a solution that is known as solution B. For test 1, they added a universal indicator paper. Universal indicator paper turned blue. Blue indicates a weak base. Okay, indigo or violet would have indicated a strong base. You should know the strip of the universal indicator and the colors of strong acids, weak acids, neutral solution, weak base, and strong base. Like strong acids are showed red color when exposed to universal indicator, while weak acids show yellow to orange color. So in test 2, they added sodium hydroxide and white precipitate was formed, which remained when excess aqueous sodium hydroxide was added. This happens with calcium, by the way. Test 3, to the third solution of solution B, aqueous ammonia was added dropwise and then in excess. The solution remained colorless. We know that calcium ions do not give any reaction with aqueous ammonia. Okay, from the table you can see that. So this is going to be calcium ion. We know for sure that the solid that was dissolved had calcium metal, which converted into calcium ion when it was dissolved in water. To reduce the pH of the solution, write any pH for weak base from 8 to 11, like let's say 11. Okay. Identify solid B. That is going to be calcium, right? Calcium ion की form में होगा. You can say that's going to be calcium hydroxide. This seems to be the only solution because they have not given you any anion, but they know that it's a base, right? So calcium has to be attached to something that is basic, and hydroxide ions actually cause basicity. So calcium hydroxide will be your answer. Okay, so there are two solids, C and D. They were analyzed, and there were different tests being done on solid C first. In test one, a flame test was done, and it showed a red flame, which indicate lithium ion. Okay, and then solid C was dissolved in distilled water to produce a solution C. And then they added sodium hydroxide to solution C, but there was no change. So basically, ammonium ion indicates ammonium ion because ammonium ion do not give any change when sodium hydroxide is added to it. And then they added a piece of aluminium foil, and the mixture was warmed gently, and any gas produced was tested, and the gas turned red litmus paper blue. That indicates ammonia. That also confirms our theory of ammonium ion, which when exposed to aluminium foil and heated, it released ammonia. We know that's a test for nitrate as well. Right? Name the gas that turned red litmus paper blue in test 3. That is going to be ammonia. And now you have to identify the solid C. It's going to be lithium nitrate. Lithium nitrate. Okay? Okay, after that, there are some tests being done on solid D as well. Solid D was aluminum sulfate, so they have told you that. And what did they do? They dissolved that in water to form a solution D. And they divided the solution into 4 approximately equal portions to do 4 tests basically. So they added sodium hydroxide dropwise, and then in excess, what would happen? So aluminum will give white precipitate. Aluminium will give white precipitate with sodium hydroxide, and in excess sodium hydroxide, they dissolve to form colorless solution. Dissolve to form colorless solution. Then they added aqueous ammonia. Aqueous ammonia may also they produce white precipitate. Aluminium ion produce white precipitate, which are insoluble in excess. Insoluble in excess. After that, they added nitric acid and silver nitrate. So it was aluminium sulfate, na? Aluminium sulfate. If they had added something of barium, then white precipitate would have formed. Now they added silver. Now silver sulfate will be formed, and silver sulfate does not have any precipitate. So observation will be no change. No change or no precipitate will be formed here. Okay. Okay, so the last part is that about 1 centimeter cube of nitric acid and barium nitrate was added now. So the barium sulfate precipitate will be formed, and the observation would be white precipitates. These questions are pretty easy, by the way. Just follow the similar format. Okay, so solution G was divided into 3 equal portions now. G and H are being analyzed. First, we are going to discuss the test being done on solution G. In test 1, sodium hydroxide was added dropwise, and then in excess to the first portion of solution G. White precipitates were formed which did not dissolve in excess. And then nitric acid followed by a few drops of silver nitrate were added to the second portion of solution G, and yellow precipitate will be formed. Yellow precipitate indicate an anion, that is iodide ions. Okay. After that, hydrogen peroxide was added to the third solution. The gas produced was tested. The gas relit a glowing splint, which means the gas is going to be oxygen. That's pretty simple here. In the A part, they asked you to identify the gas that is produced in test 3. Test 3 produced oxygen. Use the results of test 1 and test 2 to identify solution G. One thing we know that it's going to be iodide, and the other thing we know it can be calcium. Because white precipitate which did not dissolve in excess, there is only one ion that does not dissolve in excess, sodium hydroxide, and that is calcium ion. So the solution, so the answer would be simply calcium iodide, right? 1 mark is for calcium and 1 mark is for iodide. So test on solid H was being done, are done. Solid H was hydrated copper sulfate. Complete the expected observations. The solid H was placed in a boiling tube. Solid H is copper sulfate. When you are going to heat it, it is going to produce water fumes, like white fumes or white mist can be seen, right? Or you can also see that white fumes when hit the walls of the boiling tube, or the mouth of the boiling tube, they start to condense. You can also see that condensates are visible. Condensations will be visible. A condensation will be present around the boiling tube. Condensation will be visible. A flame test was carried out on solid H. So you have copper, and copper produces, I think you should know until now, that it produces a blue-green flame. Blue-green flame. And if you don't remember it, please watch my video on additions and omissions, because flame tests are recently added in the syllabus. The remaining solid H was then again placed in a boiling tube, and then they added water to it. Now it formed a solution that was called solution H. Solution H was divided into two equal portions. Now they added aqueous ammonia to it. So when you added aqueous ammonia to it, so copper will produce blue precipitate. And since they're adding in excess, so blue precipitate will dissolve in excess to form a dark blue or deeper blue solution. We've done this before as well. Dissolve in excess ammonia to form a deeper blue solution. Deeper blue solution. Now they added barium nitrate to it. So you had what? You had copper sulfate? Yes, you had copper sulfate. So barium nitrate you added. So barium sulfate will be formed, which will have white precipitate. So basically it's the same information being recycled in one question after another. Okay, so solid O and liquid P were analyzed. Solid O was ammonium bromide. Their tests on solid O, first of all, was dissolved in water to form solution O. To the first portion of solution O, ammonia was added. You know that solid O was ammonium bromide. So when you added ammonium to it, there will be no change. We know that we haven't studied, or there is no mention of ammonium ion testing in the with ammonia. Okay, ammonium ion only appear in the identification of cations using when you are using sodium hydroxide. So no change to the second portion of solid solution A. Sodium hydroxide was added. The mixture formed was warmed. The gas was given off. Obviously, the gas was tested with red litmus paper, which will turn blue, and the gas will be ammonia. No points for guessing that. It's pretty damn easy. To the third portion of solution O, nitric acid followed by silver nitrate was added. So what did we have? We had ammonium bromide. So when you added silver nitrate, silver bromide will be formed. And just like 5 to 10 minutes ago, I told you that silver bromide show cream precipitate, silver chloride show white precipitate, and silver iodide will show yellow precipitate. Then to the fourth portion of solution O, they added chlorine. So you had ammonium bromide and you added chlorine. So obviously chlorine is going to displace bromine, and Br2 will be formed. And Br2 has an orangish yellow color, or orange color, or solution. Solution turns orange. I think that would be better. Solution turns orange. So test on liquid P. In test 1, P was placed in a crucible, lightning splint was applied to the surface of the liquid and it burned with an orange flame. Lots of smoke soot was left around the top of the crucible. Okay, interesting. A few drops of liquid P was added to test tube containing aqueous bromine. Color changed from orange to colorless, which means that it decolorized bromine. Okay, first of all, it burned with a lot of smoke, so it means that it's a flammable hydrocarbon, right? It's flammable, and since soot was being left, it's going to be a hydrocarbon. Soot is pure carbon, and the color changed from orange to colorless. That means it's an alkene, or you can say that it has carbon-carbon double bond. It's an unsaturated hydrocarbon. Okay, so what do you know from this? You know that liquid P is an unsaturated is a flammable unsaturated hydrocarbon. Flammable unsaturated hydrocarbon or fuel, your call. One mark for flammable, one mark for unsaturated, and also another mark for hydrocarbon. So that's all from this video. These questions are pretty straightforward. I don't think you will have much problem with it because the same piece of information is going to be recycled, right? So these were like 2 to 3 years worth of papers. I just extracted those questions. I hope this video will help you out. Inshallah, see you in the next video.